Good afternoon, everybody. Welcome to this IMechE webinar. We've called this webinar Change Management, Making Sure Changes Don't Lead to Catastrophe. Just a bit of a summary as to how we've got here. This is the final webinar in a series of webinars that we've covered over a learning cycle for businesses that have catastrophic incident potential. We've tried to cover many sectors, and obviously this is a process industries division event, but we've tried to cover sectors outside of those industries as well. In the past webinars, we've covered the need for leadership in process safety management. We've covered the need for having firm and clear procedures in place and the right number of competent people to deliver those. We've looked at and talked about the need for audit to discover performance. And of course, the other way of discovering performance, which is retrospectively through incident investigation and the need for thorough investigation. And in the last webinar, we talked about the need for leaders and managers to view key performance indicators in order to understand and discuss what's going on. Now, of course, once we've looked at what's going on, managers may choose to make a change, which brings us to where we are with today's webinar. In reality, change management is another circuit of the same learning cycle, but there are key lessons to discover from that. My name is Richard Roff. I'm Head of Process Safety for the Costain Group. I'm also been involved in these webinars from the outset. In a moment, Richard Hellebrand is going to talk about change management in more detail. He's going to set the scene with some incidents. He's going to discuss what constitutes a change and perhaps what doesn't. We're going to talk about equipment changes and organizational changes because it's not always about just the hardware. And we're going to point out some resources that might help you if this is an area that you feel you want to improve with. We're going to try and field your questions after the immediate presentation. We have got a limited panel today due to some last-minute issues, but hopefully we can still field the questions. So please do put questions in the chat if you've got questions that are either more general nature or that have occurred to you while you're listening to Richard Hellebrand. Okay, well, I'll disappear in just a moment. I'll ask Richard to introduce himself and then set the scene with his presentation, and I will see you all a little bit later. Thank you. Richard, over to you.
Okay, hopefully you can see me, although you probably wish you couldn't. So I'm Richard Hellebrand, mechanical engineer. I've been involved in maintenance project management on predominantly chemical sites, but also powder handling sites throughout my career. Being involved with management of change almost forever, and most of my career was on upper tier Seveso or coma sites. So a bit of experience in this area. Richard sort of did my introduction for me, so I don't need to reprise all of that. I have included about 20 references when I go through the slides. So if you go into the resources tab and webcasts, you'll find the reference numbers as we go along the slides. If you click on them, hopefully the internet links will open up. You'll see PDFs, etc., as we go through it. Don't have to take too many notes. If anybody actually wants a PDF of the slides rather than just watching the webinar afterwards, then send me an email. My email address will be on the screen in a minute, and I'll send you the PDF back. There's nothing proprietary or confidential in this at all. Okay, so I'll turn my camera off and start sharing my screen, and hopefully you'll be able to see it. Okay, so hopefully you can see the screen, and I'll make a start with the discussion. The point about MOC is that it isn't just for chemicals, it's for anybody who really manufactures things, because the life cycle of a business, all the way from the conception of the business all the way to closing it down at the end, most of that is the life cycle in the middle, where we operate and maintain what we're doing, whether that be a chemical factory, oil and gas, food, packaging, whatever. In order to stay profitable, manufacturing processes have to be modified. And we also have to make organizational changes to make sure that we stay profitable. Even as it gets quite old, just replacing outdated equipment can be problematic. Poor management of these increase risks to people in the environment, particularly in the chemical industry, but as I've said before, other manufacturing sectors. For example, fast-moving consumer goods, food, drink, packaging, etc., etc. These other sectors aren't normally regulated as tightly as chemicals, so managing change is perhaps a core activity, but it can still catch you out. So I want to give some examples of what can go wrong, starting with the sort of probably the most famous original one. But when I was writing these slides, I realized that next year is 50 years since Flixborough happened. And I talked to younger colleagues in my business and they'd never heard of it. So perhaps it's time just to refresh it a little bit. So on the 1st of June, 74, there was an explosion at a recently built plant in Flixborough. It was only a couple of years old. Cyclohexane escaped from a temporary bypass pipe. 2 months prior to the explosion, a crack had been discovered in a reactor number 5. So what they did is they removed the reactor 5 and did a temporary bypass so they could continue operating. This is sort of not my sketch, but you can see what they did is they reused the bellows at either end that attached to the adjacent reactors and then fabricated some pipe in between. Now, the local management was pretty well qualified, but in chemical engineering, when they had a discussion about the failure of reactor 5, there wasn't a professionally qualified mechanical engineer in that detailed discussion. So as a result, the fabricated pipe didn't comply with British standards or other technical codes. Nobody actually thought to check the bellow manufacturer's design guide. No calculations were made for the dogleg shape line or for the bellows. They did do some basic calculations, but not enough. And the only drawing was in chalk on the workshop floor. Nobody on site appreciated that the bypass would be subject to turning moments and shear forces, which would be felt at the bellows. And if you know, bellows are designed to be linear in and out, they're not designed to twist. However, the pipe was supported by some scaffolding, but they didn't consider these other loadings. And nobody realized that the hydraulic thrust on the bellows, about 38 tons, would make the pipe buckle at the welded miter joints. So moving to the day of the disaster, just before 5 p.m. on a Saturday, the temporary bypass ruptured, venting the cyclohexane. About 60 tons leaked from the pipe and formed a vapor cloud, which ignited as soon as it found something nice and hot, probably the nearby hydrogen plant. The vapor cloud exploded, destroying the plant. It killed 28 people. 18 of them were in the plant control room. You think, well, that's pretty safe in the control room. But what happened is the walls blew out and the concrete ceiling collapsed on them, killing them. It's a point that's been taken forward into control room design ever since. Another 36 people were injured. It was on a Saturday afternoon. If it had been on a Monday or a Tuesday, it could have been 500 people. Nearly 2,000 houses, nearly 200 businesses had significant damage. Now it's not a very good photo because of the age of the plant, but this is 1974. You can see section 25A in the middle, which is where it happened. You can see the main office block to the left of it, luckily mainly vacated, and the hydrogen plant a bit further away where the ignition happened. And that's what the result was. One of the big consequences out of Flixborough was the health and safety executive started insisting on professionally qualified engineers in high hazard industries. And then shortly after, soon afterwards, Seveso, disaster happened, and then SEMA, then the COMA regulations came in alongside the Seveso regulations. So a lot happened from Flixborough. Second one, not chemicals, sugar. You wouldn't think sugar's dangerous, but as you can see from the photograph, it is. This explosion killed 14 people and injured 36 others. So what happened? Well, Imperial Sugar used to take raw cane sugar and convert it to granulated sugar. So lots of conveyors, bucket elevators, silos, various processing and packaging machines. To keep dust levels down, they'd recently enclosed a belt conveyor below the sugar silos. Steel covers have been put on. The problem is that allowed high concentrations of sugar dust to accumulate inside. An unknown source ignited this, causing the explosion. The initial explosion disturbed more sugar dust that accumulated on adjacent floors and horizontal surfaces. And then secondary explosions ignited throughout the buildings. Pressure waves from those explosions actually lifted concrete floors up, collapsed brick walls, blocking stairwells and other routes. So why did it explode? Well, you're probably aware that most powders, if you can form an ignitable dust cloud, if you sort of stir them up, disturb them enough and give them enough energy, and sugars are included in that. Sugar dust was around in large quantities because maintenance and housekeeping standards were poor. And with dust explosions, the classic is the first explosion disperses other accumulated dust into the air, which then results in secondary explosions that are more powerful than the first one. Unfortunately, this continues to happen every year. We get notices, I get notices every week of combustible dust cloud explosions somewhere in the world. In this event, the source was probably an overheated bearing on the idlers and rollers for belt conveyors. It's quite common for them to start to seize up with load and get hot. The root cause was that sugar dust wasn't considered dangerous. It was ignorance. And the enclosing had allowed the dust to exceed the LEL. The danger of enclosing it wasn't recognised in the management of change process. Here's another one. It's not particularly MOC, but it's just to show that it isn't just chemicals. Who would think chocolate would be dangerous? But chocolate is dangerous. This was exactly 1 calendar month ago today.
The search continues for 4 people that are still said to be missing from this deadly chocolate factory explosion. This happened about 60 miles northwest of Philadelphia. Another body was pulled from the rubble yesterday. That brings the death toll now to 3. 1 person was found alive yesterday. The explosion destroyed 1 building and it damaged the neighboring building with apartments that injured dozens.
Okay, so that's the after. I won't show you the before because it looked like the building on the right. It was a building. Now it doesn't exist anymore. It killed 7 people. And the root cause, we don't know it for certain because it's only just happened, but it's likely that there was a dust explosion of powdered starch because you use powdered starch when you're doing mouldings for chocolate. And it's well known. In food and packaging plants, there are a lot of process safety risks. They're probably not thought of as process safety, but things like ovens, furnaces, refrigerants, oils, powders, they can all have dangers. My last example, again, not particularly MOC, but just to show the breadth of process safety problems that there can be. This was at a brewery in 2016. And this was a death from an ammonia leak, or deaths. Because when they wanted to remove an ammonia refrigeration compressor, they hadn't implemented safe isolation standards. The principal HSE inspector said industry guidance on safe isolation of plants should have been followed. This would have ensured that a higher level of isolation was in place for prevention of exposure to this highly toxic and flammable substance. The case underlines the dangers of not following industry guidance. There's plenty of guidance around. You just need to look for it. In this particular case, there's a HSG guidance, safe isolation of plants and equipment, but there's also the Institute of Refrigeration has got various safety codes for ammonia and other refrigerants. I've put links to them again in the resources. So that's just a quick look at some disasters. I could talk for hours about disasters. I don't want to. Luckily, the IMechE's done some analysis, and it's all free. If you download this document, they've taken 52 of the worst process safety incidents across the world, from sort of Flixborough onwards, and they've analysed them. It's pretty good. There's one-page summaries on each one of them, and they're to share root causes and raise an awareness. When you do the analysis, about half involved poor management of change, and 7 of them, what's that, a seventh more or less, MOC was the actual key root cause. So, enough talk about disasters. Why do we need the MOC procedure? Basically, nobody knows everything. If you try and do a risk analysis on your own, you will miss things. You'll have your blinkers on, or you'll have a lack of knowledge, maybe focused on what you want to achieve. It sort of needs some independence on to look at it. Even small teams can get carried away with that, with wanting to implement an idea they've come up with, think it's a great idea, but perhaps haven't got the expertise in the team to assess it properly. So some independence always helps. So this, for these industries, there should be some form of MOC procedure. There should be competent assessors, some checklists to consider everything that could go wrong and what precautions are needed. It's just a bit like flying. You know, pilots have a pre-flight checklist. If you have a checklist, you're more likely to consider everything. The complexity depends on the hazards. If the hazards are relatively straightforward, it can be a really simple procedure. A piece of paper might be sufficient, but then at the other end, it can be extremely complex. Now, with process plants, the things that form your basis of safety are the original plant design, operating maintenance instructions, training, permits to work. And the only thing that can create a hazard after that, if you follow all of that properly, is change. So MOC is important. It's a sort of a topic across particularly the United States and Europe. The CSB, the Chemical Safety Board in the US, they did a safety bulletin about management of change after a few disasters. And they said that you sort of need to include some things in your system. Safe limits for variables and activities, and train people to recognize when something is significant, so that they know when to say, oh, maybe this should be an MOC. Multidisciplinary specialized expertise. Appropriate hazard analysis techniques. It could again be a piece of paper, could be a checklist, but it could also be a full HAZOP or something even more complicated. Authorization changes at, depending upon what the hazard and the risk is, then it needs to be authorized at the correct level. And things need to be in writing. The new operating procedures, the limits, the hazards need to be written down, so people coming on, for example, on a shift team, know what it's about and why it's about, what the consequences are. And then training as well, commensurate with complexity. Again, something could be just a quick briefing, 10 minutes, or it could be something more extensive. And then if you've got this system going, if you do a lot of MOCs, particularly, periodic reviews to make sure the program's still effective. I'm not going to go through this list in too much detail. It's things that need MOC, so physical alterations, changes of materials. I can remember working for a chemical company where they changed a reboiler from a hastelloy to a stainless. Someone made a mistake, and suddenly we'd have a big loss of containment. Someone hadn't picked it up in the purchasing.
Richard, just to break in,
yes,
a couple of questions around MOC. So for everybody, people that might be joining into this kind of subject for the first time, we mean management of change. So when we talk about MOC, we're not talking about materials of construction, we're talking about management of change in this case, and that's the subject of the webinar. So just for clarity, and I'll disappear again. Thanks.
No, that's a good point. I always pick up on other people using too much jargon. I put it on the first slide, but yes, it's shortened to management of change. Going on with the list of things that need it. Anything that changes your sort of line diagrams, there's other technical diagrams, because people refer to them and you may not realize who refers to them. And if you change a drawing and they don't know about it, maybe they're working off an old version. Changes in process control or software. Safety, anything safety devices should be considered as management of change. Anything that's a permit to operate. New raw materials can bring in hazards that you may not expect. A lot of us had this when the REACH regulations came in. We had to change raw materials to something equivalent, but they were never quite the same. There were different hazards. Things with environmental impact, organizational change, which I'll come back to that afterwards. Yeah, the list goes on. I'm not going to go through all of this. It's in the slides. But changes in building are worth noting, particularly when things become occupied when they were unoccupied before. And also temporary changes. I know Rich will come back to that as well, because they're the ones that can often bite you, because you think, oh, it's not worth doing this for such a short-term change. And then demolition. There are things that don't need management of change. Most maintenance, if it's done by competent people and they know what they're doing and it's within their experience, that's fine. Replacement in kind is also fine. But again, things like materials of construction, change a flow meter, it looks to be exactly the same, but you can only tell by the little reference numbers in the model number what it's made out of. Maybe it's moved from a stainless diaphragm or a tantalum diaphragm to a stainless diaphragm. It needs someone competent to look at it. Change operating limits. And then testing, diagnostics, calibration, that's fine. We train people to do that, as long as they've got something that covers what they do and they've got some proof of competence and there is a risk assessment of some form. Likewise, temporary connections, people have to troubleshoot. You inject signals, you do all sorts of things to test things out. That's fine as long as it's closely monitored and removed. One of the big hazards is someone does a calibration on a pressure transmitter, they isolate it, inject a signal into the transmitter, forget to de-isolate it afterwards, and then the control systems just see the last recorded pressure and maybe it doesn't change, so it's no longer effective. Temporary or urgent repairs, everyone gets leaks and sometimes you have to put a patch on them. There's not a problem with that as long as it's discussed and documented, properly looked at. And then anything not related to process equipment, you don't need to do management of change for notice boards or crazy stuff. HSE, Health and Safety Executive, have a document about organisational change for major hazard industries, because they say that although the motivation for the change may be financial, major accident prevention must be regarded as core business. And things like a recession, there's a decision to people have to be made redundant for whatever reason. But if it affects an operating team or the expertise that is available to back them up, it can reduce the competence levels. So then suddenly human factors are becoming a real issue and could lead to a failure and shortcomings in the operating standard, and that could lead to a hazard. If you're already SEVASO or COMA registered, you probably have to talk about those changes to the competent authority. We're not talking about recruiting someone or one person leaving, but proper organisational changes. I'm not going to go through this flow chart. Again, it's there. This is just an extract from that little document that the HSE published, but it talks about people being clear about what they're trying to achieve, that they do a proper risk assessment, they really consider the competence levels to make sure they're sufficient to actually do what you need to be doing and stay safe. Again, this is from some other guidance from European Commission. They have guidance on Seveso common inspection criteria, and they have a document about management of change. Again, it's in the references, the resources. And it's just a flow chart about how you go through it. Check whether someone proposes that and you decide, well, okay, we're going to go ahead with this, but is it going to be temporary or permanent? Is it it's going to need some form of analysis? Depending on how big it is, it might need presentation to more management. Then there'll be some approval, and then someone goes ahead, does some more work, works it up, authorizes it, and then if it's a Seveso one, a big, they might actually reject it or ask for further work to be done, and then the change is made. And then there's this term pre-startup safety review. It's sort of an American term, but we've adopted it. It's that big checklist before you bring the chemicals in or start up that hazardous nuclear reactor. So this is sort of at the top level, if you like, the big stuff. So, but at the other end, if you look at and just look at management and change on the internet, you'll find so much stuff, it can be really confusing. So what I'm going to try and cover in the next bit of the presentation is a nice simple paper system that I used for many years, and a lot of you will probably recognize where it came from. I'll also talk a little bit about other free resources that you can get to do this, and then talk a bit about software. So if you look in the resources, there are two Word documents. There's a procedure, a template procedure, and a template form. I'm just going to go through the form that's there, talking about how I'd fill it in if I was doing it. So the first thing is it's an A3 form, and you've got various pages of A4 shown in the next slides. What we typically used to do is print them out on coloured paper so that they don't get lost on someone's desk. It's obvious it's an important document. So the top section is pretty obvious: description of the change, give it a reference number. If it's going to be a temporary modification, you want to do some time limiting on that. That could be, for example, if you're waiting for a spare part, something's broken down, and you need to buy a spare or a replacement for it. So there might be time limited. It might be just for a shutdown period. It could be something to do with your control system. It could be, and then it's usual just to write down what are the HSE and financial benefits. Doesn't have to be exact, it's just approximate. At the bottom of that page, it's given to someone who knows what they're looking at, someone who's competent and trained, who now does a quick look at it and agrees or disagrees that it's a good idea, and then they'll send it to one or two other people to look at, and then nominate the names. I said there's a lot you can go wrong with management of change. Well, that's why you need a big checklist. And this checklist, again, it's an A4 page, and you can edit it to your heart's content on the Word document, make it country specific or company specific. But what we would do is, as an assessor, I would just go down all of these titles, underlining things I think might have relevance. So, this is a bit complicated. I think I need a HAZOP. Well, that's Hazard Study 3. This is the 6-stage ABB system, but Hazard Study 3 is HAZOP. And I might need some safety instrumented system, so underline that. And then you'll find that comes in further on in other parts under the engineering. But basically go down, underline everything, and think, I need to think about those. And this is the bottom of the page, the same thing again. It's just more things to underline. And this is a moving feast. You modify this checklist as regulations change or as the technology changes. And then with all those underlined things, there's two pages of A4 facing each other in the middle of the form. So in other words, an A3 sheet. And each one of those, you would put a factor down. So for example, on the last one, or 2.1 Seveso. So I might write 2.1, then I might say, consult with health and safety executive, give it to someone, and they initial to say that they've got it, So each person initials to say that they understand they have an action to do. If there's something really important, critical, like we need legal permission to do this, then it's going to be, we tick it there. And what that means is that when we authorize the physical modification to go ahead, we won't authorize that until at least that is ticked on every action. Some things need to be done before commissioning as well. So again, I think of something like a safety instrumented system. You might need proof testing of it or engineering commissioning of it before completion, before commissioning. So we fill in these actions, say who's going to do them, and say when they need to do them. And when they've finished doing them, they just write a comment in here, maybe provide the evidence, and say it's finished. And this is just the top of the form. I've done this where we've ended up with 4 or 5 A3 sheets, all filled in with like 40 or 50 actions per sheet. And then the authorized person then gets it back. He sees that the essential, he or she sees that the essential actions have been done, but then looks at it and thinks, oh, hang on a minute. What's the worst thing that can go wrong on this? And there's, depending on what you answer that like, then that will decide whether there's a formal hazard study or something else. In which case it might then go to an independent chair for that study. When that's completed, the chair for that study signs to say it's completed, and then we go through towards final authorization to do it. So that's appropriate for a big project. For a small project or a small mod, I would just cross it out and say not applicable, because it's not. And then the authorizer says, well, I'm happy it's been adequately defined, consequences have been considered, actions have been planned, risks reduced to an acceptable level, it can be carried out. And we would normally have 2 authorizing managers, a 4 eyes approach, 1 engineer, 1 production person. Not only that, often you give it to an engineer to engineer it, put it in, but they might not commission it. Typically that can be someone different. So there's sort of an installation person and a commissioning person. If it's particularly safety critical, might put a 3rd person in there to verify that it works. And also some dates, when we are expecting commissioning to be complete and when we expect the final mod to be complete. And the final mod completed means all the paperwork, all the follow-up stuff, all the I's crossed and the dotted and the T's crossed. And then that's the sort of authorization to go on. First, someone puts it all in. Again, it could be something as simple as putting a pump in up to a full process. And then they answer some questions. Are you satisfied it's been installed as described? Have all the actions been completed? There might be some outstanding actions that are not a problem. If they're not vital, they could just be listed. And is it ready for commissioning? And then the person who's commissioning it fills in the next bit of the form. Well, yeah, I commissioned it. I didn't find any hazards, or I did find hazards. What have I done about it? The key stuff's been updated to reflect the changes. And is it acceptable for continued operation? Sometimes you might make a slight change to the scope, but it's unusual. That involves discussion. So that's it then. So it's installed, it's commissioned. The very final bit of this form is right at the end. Goes back to the original person or the most senior person who checks out, yeah, all the hazard studies have been finished. Are there any further actions? Have all the benefits been achieved? And signs to say that all outstanding actions are complete and the site records reflect the changes. That's it. The mod is then finished because all of the paperwork, the drawings, the training, operating procedures, everything else is updated. So feel free to take it away, use it. It's there. This is just one I did, what, 4 years ago now, isn't it? This was a water seal gas holder for vinyl chloride gas. So that if you don't know about these, basically the top, we call it the bell. It goes up and down and it floats in the water with a water seal around the edge. This was protected for under pressure. It couldn't be vacuumed in by safety instrumented systems on the outlet pipes. So if the pressure started to drop, it would trip everything. But the health and safety executive discussed it with us and suggested, well, you really ought to put vacuum relief valves on the top as well as. We agreed with them, so we did it. So this is just the front page, but it just shows you it doesn't have to be a fancy system. There's quite a lot attached to it. I'm not going to show you all that, but it can be quite simple. There's also some free templates online. If you don't like the Word form, you can download them. I've not tried that, but the links are in for both of these resources, 10 and 11, that you can look at those. I have no connection with these people at all. You can probably find other stuff as well. It's just what I found. In software tools, it's quite possible to write your own paper forms, but you can also use spreadsheets, databases to do this. There's nothing wrong with that at all, but you should remember that the people who write them and understand them need to be around, and if they suddenly leave, you end up with a system that becomes unsupported. So just be careful what you do with that, at least in documenting it anyway. There's a lot of suppliers of commercial management of change software. These are really targeted at large organizations with multiple sites. I've actually put 6 links at the back of the presentation in the resources. I have used 3 of them, and they were all very, very professional, but they are targeted and complex. They use workflows, and depending on what checkboxes are ticked in the software, then preset flow, it goes off at a tangent and down a particular preset workflow with its own checklists and approvals, depending upon what the criticality is. So this is sort of a typical simple workflow in the software. Someone had actually put the draft in, then some sort of gatekeeper, administrator, who typically an engineer, will look at it and then say, no, that's rubbish, that is, you can't do that, and discard it, or else send it for some analysis to someone else. This mirrors really what I showed you on the paper form. Then, depending on what it is, there might well be a startup or a post-startup review, and then the final approval is that sort of M5. It's when everything is done and finished. Doesn't work in the real world all the time because things go wrong. So we have to have emergency ones. People work at nights and weekends. So typically what will happen there is, certainly in my industry, chemicals, there'll be a duty manager or duty engineer of some sort on call. They get phoned up. We need to do something. There's a problem. Over the phone, they'll do some MOC analysis. Maybe they'll get on Teams. Maybe he or she will phone another manager or engineer to have a discussion, and they'll verbally approve it and say, right, get on with it. And then the shift team does it. But it's expected that that document, even in a minimal setup, will go on to days then for analysis when people come on to days, and then it follows the normal procedure. And the advantages of the commercial tools are you can get dashboards and fancy reports and bar charts and pie charts and all these other things. Again, just look through them. There's demos available, but they're not cheap because people are in it to make money. Obviously, that's the business model. If this is all a bit too much for you, there's 2 really short documents about management of change. They're both targeted at Seveso facilities, but a lot of what they say makes sense in other sectors as well. The MAHB is the Seveso one from the European Commission, and then more locally in the UK, at least, the Health and Safety Executive. Again, the links are there. If you really want to go a bit further about this and need to have some more expertise, there's sort of the 2 big organizations for PSM, if you like, management systems, process safety management systems. The CCPS, which is a spin-off of the American Institute of Chemical Engineers, they have a book about this. And the Energy Institute represents oil, gas and energy companies, and more recently, in the last 3 or 4 years, they've produced a process safety management framework, and element 12 covers management of change. my final slide is all those references, not going through them, but if you look at the number on the left, 1 to 20 in the resources, 1 to 20 in webcast, you can click on those and you'll get what they are. If you miss it for some reason, ask me for the PDF, you'll get those right there, you can type them in. That's me. I've taken about 40 minutes. We'll open for questions in a minute. Again, my email address is there on the slide. And if you want a CPD certificate, Continuing Professional Development Certificate, email Murat Islam. Richard, if we can leave that up.
Yeah, that's no problem. Yeah.
Then it just leads people, because it's difficult writing things down and remember things. You can also give feedback to the IMechE about whether you found this useful or thought it was useless.
Preferably the former, clearly. Right, so there are a couple of comments and questions. Hopefully, those of you that wanted Richard's contact details can quickly jot down that member@imeche.org address. In terms of the materials overall, all of the references are available, and I think Molly has gotten back to everybody in the chat as to how to access those, and we don't quite see exactly the same things that you see. So one of the comments that came in quite early on was, I think you were probably describing Flixborough at the time, Richard, was it sounds like, I suspect the writer means the Bhopal disaster in India. And I think I would reflect that, unfortunately, yeah, these disasters tend to come around on a sort of generational basis, and potentially in different sectors of industry and different parts of the world, and it's concerning that we can't learn and embed our lessons from the events. But yeah, there certainly are some issues of workarounds and temporary change that were going on at Bhopal as well. So I just wanted to respond to one of the first comments. So I just thinking about the comment you made, Richard, regarding hazard study or the IMechE 6-stage hazard study system that's familiar to anybody who might have worked in chemical, oil and gas industries, but might not be for others, is one of the early prompts that we might want in thinking about a change is, well, when should we get a whole load of brain power involved in assessing this, and when can just a couple of people at site assess it? So I would reflect a system that I used when I worked in the chemical industry, which tried to assess 3 aspects. One was novelty, so how new is this change compared with what we know about? The other is complexity, so how many things are likely to be affected by the change we're proposing, and then scale, so is it just a huge thing that we're trying to do? And we had a very simple sort of score 1, score 2 approach to those, but several score 2s was a prompt for us to think, well, maybe we should apply a hazard study process and not just choose our A3 form. Wonder if you'd like to comment on that first, Richard, and then I'll get back into other questions.
I sort of agree with you, but I work across Europe, and other industries don't even use HAZOP. They use something similar.
Indeed.
And because particularly with Seveso, it's European wide, it's country specific. You're allowed to interpret it in your own legal framework by country. So some are more rigorous in areas than others, and it can be a simple checklist. And certainly the companies I deal with is in Germany, for example, don't use a 6-stage process. They only have the HAZOP, or they would call it a Sicherheitsgespräch, safety discussion, or various other versions of that. So it's the most important thing is that the people who look at it first have experience, good lengthy experience and knowledge, because they are the gatekeepers. They need to be experts. They need to have enough expertise of just not the technology, but also the legals, to be able to look at these things. because I think you can write it down in a process and it all looks fine and fantastic, but if you haven't got the right people, that's a problem. And Trevor Kletz once said something to the effect of, well, organizations don't have memory, do they? It's people, and people leave.
Yeah, indeed. So I think whether there is a formalized study system, or whether those three questions of novelty, complexity, and scale just lead to more brain power is sort of neither here nor there. But it's worth, as you say, the initial assessors understanding how big a deal is this, and therefore, what brain power do we need? Do I need assistance? And it's particularly true for small scale organizations, because where would one normally get one's advice from? And it may be external, and it may be that you have to stop and think about external advice. Okay, thank you for that. Couple of questions have come in. One comment, I think, which is relating to the idea of as-built design and during design impact assessments. And I've been interested in this area. I guess the organization I work for is an engineering and construction organization, and routinely in the world of infrastructure delivery, there is the idea of as-built design, i.e. you go and make sure that the design reflects what you actually built. For me, there's an interesting, or I have an interesting concern about that, which is, if we didn't build what we said we were going to build, are we sure that what we have actually built fulfills the needs of the original client or the original requirements? So actually change while we're still on a CAD station or the drawing board as it used to be is not requiring the same kind of input that we've been talking about here. But when we're actually into building it or maintaining it or modifying it, then a change to a change can present some concerns, I guess. Would you agree?
Absolutely. I think the point, there's two factors here. There's a commercial or cost time factor with project engineers, and I've been there, done that, where there's a deadline, you're heading for a particular turnaround or period when you've got to have it delivered by, but they want to approve it before all the HAZOPs and all the other changes have been finished. And it's important that you push back on that and say, no, we've got to finish the safety stuff, the important safety stuff first. And once you've agreed the scope, that if there's an MOC, if you write down a management change form for a project, for example, and the scope changes, you need to do a new MOC for the change.
Yeah, well, yes, it's a change to a change then, isn't it? Or a rethink of the original change in its now modified form. Yeah. Okay. Yeah, I mean, another commenter has talked about the fact that perhaps civils and the building world haven't applied certainly the sort of hazard study methodologies in whatever form over the years, and that can lead to issues up to and including catastrophic incidents like the fire at Grenfell Tower. Can we comment on the need for such processes to become standard outside of petrochemicals? I mean, I'll start by saying, I think they do need to become more standard. And this idea that professional engineers can make these assessments, but we have to give them the chance to make the assessment, is really underpinning everything we've talked about. Although you've talked about quite formalized systems, Richard, for me, it's about the right brain power making professional decisions.
To use a very crude analogy, this is a pub quiz, right? You can't, as an individual, however expert you are, answer all the pub quiz questions as well as a team. It's straightforward. The more people you involve, the more likely to get an accurate answer to the question. So you just have to, infrastructure is really hard. My background is chemicals and processes, so perhaps less than public utilities. So perhaps I can't really comment on what you said too much, other than just get the right people in the team.
Yeah, absolutely. And so for me, there's the tripwire that says do an assessment, And then the second question is, who's doing the assessment, and do they have the right skills and experience? Yeah, absolutely. Okay. There's a question coming in really about future events and wondering if a presentation on industrial equipment might be possible in the future. And yes, it might. And it's probably not Richard and I are the as presenters, but we will absolutely bear that in mind. Thank you. Okay, somebody's saying...
I mean, comments on that, sorry. I mean, often we buy equipment packages. Like thinking of the ammonia example with Carlsberg, but not directly, but you buy an ammonia refrigeration unit and you think of it as a black box and don't think about it because it's in the corner. Those things need thinking about, particularly the interfaces with the larger system. I think so. Equipment, yeah. I mean, I've done some stuff on safeguarding machinery, etc. So that's fine, but that's more about occupational safety. It's not about what happens if 20 tons of ammonia leaks out.
Indeed, but I think the black box thing is interesting. In my early career, I worked for ICI, and we had a little bit of a joke in amongst the business that it stood for I changed it, because we kind of routinely change stuff. And however, the interfaces of black boxes that are not changed from their manufacturer specifications become the problem area, don't they? Rather than each black box on its own. So yeah, that's a really interesting point. Thank you. So somebody is asking whether a whole department needs to be created for this. I would argue not. I mean, there's a need for potentially some admin and workflow, but actually it's engineers responsible for integrity that ought to be signing off on changes, because changes might affect the integrity that they're responsible for. And I think that's really where you are coming from, isn't it, Richard?
Well, I think those of us with, I won't say an ICI background, but a lot of industries copied what ICI did, certainly around the UK. And since Flixborough, they would be used to the concept of responsible engineer for disciplines on high hazard sites. Those are the people who need to sign off. It doesn't have to be them, but they need to be competent and they need to know and be available to that site. So you can have a department that does it, that's fine, but it's better decentralized, in my opinion, with one or two experts centrally to help you.
Yeah, so expertise in a department is fine. I have to say, when I was a responsible engineer for high hazard equipment in the chemical industry, you wouldn't have been changing anything that I was responsible for without my say-so. So, base it on that, and we'll get somewhere. Okay, there's a question about a revision to a technical specification. Not quite sure exactly what sort of technical specification, but perhaps that's along the lines of materials, things like that. I would say some understanding of what that technical specification relates to is worthwhile, and therefore we're back to yes, probably. Does that mean you don't go ahead? Probably, it depends. An example I would use from my home life is when we started to use heating oil that had a significant amount of bioproduct in it. The soft rubber gaskets began to fail. Now, I knew that was likely, and I also discussed it with the guy who does my servicing, and we looked out for it and got it sorted. But that's the sort of thing that I think you referred to, Richard. Sometimes tech specs meet a general standard, but move between that standard and can cause problems, can't they?
They can. I mean, in an ideal world, you do the safety studies first, whether they be HAZOP or FMEA or whatever other risk assessment is, and that's taken in. In fact, you do the design and incorporate the safety requirements and any feedback from those studies, and then I don't really care what the engineers do as long as it's within the scope and the limits that you've put. It's fine. You don't have to tell them how to do everything. And if you need to make minor changes through I'd say a project, but a project, as long as there are a few discipline engineers and you've discussed it and documented it, you've done a risk assessment. You don't have to start off a whole new process for every single small change, but you should document the risk assessment, get someone to sign off on it.
Yeah, absolutely. Okay, just a quick one from somebody who's in the rail sector. So the rail sector uses a process called the Common Safety Method for Risk Evaluation, and there are criteria for what amounts to a change in there. So if you're involved in the rail industry, then what do we mean by a change that results in a lot more studies has already been defined, and it's been defined across Europe and the UK because of the interoperability regulations. So that is useful, but for me, it's also set at quite a high level in my experience, and so what's regarded as a change is pretty significant to trigger that kind of regulation. There are changes below that you might want to be thinking about at organization level or even project level. But yeah, thank you for that comment about the common safety method. Okay, there's a question about, has there been any research in the fast-moving field of artificial intelligence or AI? I suspect it's going to come. I'm sure there's been lots of research in principle, but not necessarily that I'm aware of around management of change. I think one of the things that it might be useful for is the extensive checklist that Richard showed of stuff to think about, to perhaps draw our attention to some of those. I would be slightly concerned about using it to respond in any way as part of the authorization process.
It is part of a lot. Part of the ongoing discussion across the industry is Industry 4.0 and automation, and suddenly AI is becoming available. So some of the process analysis software now is AI based. I mean, AI is just fancy algorithms, but nevertheless, that's what it is. And that's fine for looking at things and trying to draw out trends and do things. But in our industries, you would never have the control system together with the safety system. One would be independent of the other, and AI should never go into the safety system. It can perhaps go into control system within limits, but it's not ready for it yet. But I'm sure we have to watch this space because it's coming.
Yeah, I mean, for me, you talked yourself about colleagues who had not heard of Flixborough. I'm bringing people's attention to the things that, the organizational learning that, as you quoted Trevor Kletz, doesn't exist. How do people get better at knowing what they need to know? I think there's a way to go there for sure. Thank you. Okay, there's a comment about electronic MOC, or indeed perhaps this is relevant to any form or admin system, is that once we get beyond approval, that's where control of what is actually happening starts to break down. So this relates, I think, a little bit to have we done exactly what we said we were going to do? Did we build what we said we were going to build? And have we fixed all of the records? For me, the concerns I always had when I was working in the chemical industry was around, have we updated the records? Because that's where we start from. Okay, you're going to end the show, right? Yeah. So yeah, good point about actually what is required for a good process here is thoroughness, / pedantry, and getting all the way to the far end. So things like pre-startup safety review, actually been doing with all the right people, and then making sure that all the records are sorted. I think there's a question. Okay. Right. So thinking about personnel changes or organizational changes, there's a query around how well do we think that works. In my experience, it is by far the more difficult part to manage because, let's say I'm part of the process, I've got some expertise and I work in a particular facility and I'm moving on to another job. Somebody comes in to follow me who's not quite as experienced. So how do we make sure that the person with less experience has the right support or gathers that experience or gets whatever knowledge they need to get before they authorize. That's one thing, but even in the decision making during authorization, I think this area, firstly, is not spotted. I think personnel and organizational changes happen, and the organization then goes, didn't we used to ask, name of person X here? Oh no, they left the organization years ago, and okay, now what do we do? In fact, that was relevant to the Flixborough incident that you started the presentation with, Richard. The lack of mechanical engineer was also a result of an organizational change in itself. Any thoughts from your own experience on organizational change, Richard?
This is something that everyone in the industry is struggling with. It's succession planning, full stop. It applies to all, not just this area. I've been talking to colleagues in Europe again, looking for standard online training courses. I know you get involved with training in the UK sector, and it's the same across Europe. You sort of need to identify these, but the problem, I don't want to sound too old and fuddy, but training very young people is they've never been through or seen a process disaster. So the important thing about this is to share relevant stuff. So Flixborough, where I used to work, we had 6 batch reactors and had a control room in roughly the same position, and the reactors were similar size. That was a perfect one to show with them because they could, oh God, that's here. So it's important. There's so many to choose from that we target the training, not just about procedures, but relevance. So there's nothing like a video, and so that succession planning needs to happen 12 months before someone's going to be retiring. If they leave suddenly, that's a problem. But
sure, but if I had particular skills that were important to my organization, the organization should understand what it will do if I don't come into work tomorrow. And there are numerous reasons, from the very bad to the very good, for why I might not come into work tomorrow. But actually, it is something that organizations can do in advance. Succession and what if are both questions that you ought to answer for yourselves. And if you don't think you know what the answer is, then at least have the appropriate emergency plan, which might be, well, we need to get that expertise from an external consultant or some such thing. It is important to think about in advance. The tricky part I always found with organizational change is the risk assessment, because there are many more tricks you can play to get expertise available, even if it's not available on tap, sitting at a desk waiting for a call. That said, there may be more work to do here.
The other thing I was going to say, if you're in an industry sector association, make use of it. If someone leaves, just phone up a colleague, because we're talking here about health and safety here. There's no commercial problems. Just ring someone else up. They can probably help you out, or at least point you in the right direction.
Yeah, absolutely. That's a very good point. So we Richard, your presentation has regarded the process industries, and that's your experience, and to some extent it's mine. It is worth noting that I think this kind of thinking should and can apply in many sectors. Indeed, with the introductory presentation I made several years ago to this series, I talked about workarounds and degraded working and changed procedures, not only because of emergencies, but as you referred to in your presentation, Richard, something fails, we need to manage safely without this item. We can't always stop the facility that we have to hand. So not following the procedures today or the guidance today is something that can be thought about and assessed. We normally follow standards and guidance, but occasionally we can't. Therefore, brain power applied to the problem, and the right brain power with the right experience will get us what you might regard as a as an engineering decision or a fit for purpose decision. So as long as these things are recorded in the way that Richard was describing, then generally we've got good shape. Just one quick final one on a slightly different subject. You know, when is a temporary repair a temporary modification, and when is it not, do you think?
If you've got a defined safety system and that lists the equipment that's in it, and you're taking something out or modifying something in that system, that's the sort of, from an engineer's point of view, that's the first. I mean, I did a long list of these things, but that's the basics of it. If it's going to affect something that can affect safety, then you should look at it more closely.
Yeah, absolutely. I mean, there are certain sectors that use various kinds of temporary repair, and some of them feel and look more permanent to others. But in general terms, those repair methods have also been thought about in advance as to when they can be applied, how good they are, and so on. And injection leak sealing is one of those for anybody with piping and flanges. Wrapping up pipes in the water sector and clamping pipes in the water sector is pretty common. And there are no doubt others in the sectors that our audience will be familiar with. As long as they're not applied willy-nilly and they may have some authorization process associated with them, then in general terms, I see those as managed by an equivalent but separate system to management of change. But equally, management of change might apply if you want to make some kind of one-off repair that you've never done before. And I think we go back to the skill and experience of the people who make the first assessment, I would say.
I get worried with MOC for two things. For a plant that doesn't have any, or very, very few of them, and for a plant that has lots, because they're both getting it a bit wrong. So there's somewhere in the middle, there's going to be a manageable workload. But if the procedure is so onerous that people don't want to use it, that's far more dangerous. I prefer to have a simpler procedure that everyone uses, because you can always say, oh, this doesn't need it. You don't have to fill it out every time. But if you have it a complex system, people prefer not to use them. They prefer to avoid them. They see it as bureaucratic, and that's dangerous. So it's about horses for courses.
Okay, absolutely. So I think probably we are done, both for time and pretty much for questions. There's one final question about the email address to request the slides, but we'll get back to you individually on that. So thank you for joining us today. I would say that we do have in mind a seminar for later in the year that might well be more of a face-to-face affair to try and round up the whole series here, to reflect back on all parts of the learning cycle. I want to thank Richard. I want to thank Molly in the background for all the work that she's been doing. So watch out for a seminar. If the subjects have interested you and you've got something to say, and you can help to bring these ideas of catastrophic incident prevention and process safety management to whatever sector you're in, whether that's sectors traditionally associated with pipes and valves or entirely different sectors, please do. Please feel free to feedback on this webinar and so on. But that being said, I'll close up today. Thank you for joining us, and hope you have a good afternoon.
Thanks for watching.